And our next presentation will be by Giacomo Beccari, who will give us a demo of the new P2 tool.
Okay, it's okay. So we'll have to work.
You have to work a little bit.
Yeah, okay. So this is I guess this is the first hands-on session, right? So hands-on sessions are very scary because if something can go wrong, it will during the hands-on session. It's always like that. So thank you very much, Monica. This was really a great introduction. It's a great help. I would like just to briefly recap on some concepts. So basically what happens, you have a scientific idea, as following the beautiful description of Henri yesterday, then you choose your instrument, then you write a proposal, following the tips that Dimitri and Nando gave yesterday, so you get accepted, and then you get a web letter, a notification from ESO saying, congratulations, you got your time. And now, what you have to do is to use P2, which is the tools that allows you to create observing blocks, okay, which are these, entity that allows you to set up your instrument to make your observation at the telescopes. That is something I would like to emphasize. I always say that. So, in order to create OBs, there is a basic thing that you need to understand. You need to know at a certain level your instrument. And so this means, and this I know is very tedious sometimes, you need to read the documentation. And I really emphasize this, and I'd like you to understand this. I acknowledge, as I said, that this is a bit of a pain sometimes because the documentation can be very technical, but the more you try to do it, the better, the quicker it will be for you to get yourself, oriented in the documentation. But it's very important because you must know how the instrument is behaving, what you want to achieve, and which is the best way to achieve what you want. And very often in the document that our instrument scientists, we have here the instrument scientist Andrea of X-Shooter, they know the instrument very well. They document all the templates that you have to know, all the modes that the instrument has, and they document in the user manual. And it is very critical to know what this instrument is doing and how to set it. So please read the documentation. Also the web pages, there are very important information on our web pages. So each instrument has a dedicated web page where you can find news about the instrument, you can find characteristics of the instrument, the basic knowledge of the instrument. So please go and have a look. So once let's say now you know your instrument and you're ready to go. So the web page, so now we have a tool which is called P2, which is indeed replaces the previous version, which is P2PP, which is the tool which was a desk. I mean, and basically it was a tool that you had to install on your machine. Now you do not have anymore to install the tool because it's a web-based tool. So you open your browser. You can, if you want, I see laptops. If you want, you can follow with me and typing yourself on the laptop. There is a demo account that you are welcome to use. Actually, we encourage people to use it even during the phase one because it will allow you to optimize your strategy. So I have already an overview of how much time will you cost you to have a basic of the base of your observations. So you type on your browser www.eso.org. Oh, there is one W too much. Sorry, because I don't see it from here, so please apologize. Okay, there already. So this is the link you have to use, and for the ones which use if you want to try now, you can use the demo. So you do P2 demo. Okay, you add demo. Now I will do it. So this is if you use the P2 normal. So if you want to use the demo, just type in. Let me try again. Okay. Like that. Okay. Press enter, you will be already automatically logged into the pages. Okay. So let me go through the P2 so I can show you what in a normal, let's say in a normal situation. So yes, you always have this. Okay, so you're prompted with a login page. Then you have to log in with your credential, which is the one that you have to do. You have to have even when you submit your proposal. In this case, I use a technical account. So this is my username. Okay, password. Okay, and I logged in. Okay, so now I am inside the tool. So let me emphasize. So I will use the mouse so also people online can see. So this is how is the page organized. So can I make it maybe screen? No. Okay, it was already. Okay. So on the top you have a number of tabs. Okay, you can use, and then we will see now what they are for. And then I want to emphasize you have a help pages that you can use. I encourage you to use them. So this is organized in two ways. So these two are, in fact, two. If you click them, it will open your mail client and it will send an email to us with, if you want to ask for help or if you want to give us feedback. This is very important for us. So please do it. While you are using it, you find something that is not clear, the documentation is not clear, or the tool itself doesn't do what you want, or there is something that you think you should do, then please just send your comment to us and we will receive it. And this is very important, especially now at the beginning that the tool has been released. We will learn from you. So this is very important for us. Then you can also click on the user manual just to show you. Then you go to the ESO pages. And here there is some basic description. There are very important information. Yes. There is a small video showing the basics of what you need to know when you prepare phase 2 material. And then there are some basic definition, basic concepts, definition of a science observing block, of what the calibration block is. So there are very important information that I will encourage you to go through. And there is also a link to the demo server, so you can click on it and then you will be directly directed to the demo pages where you have all the instrument and you can start to do some tests, and then there are features, description of features. So please go and document and learn about the tool itself. Then, so you're logged in, as I said, so you got time at the telescope. Let's say you can get the time as a service mode run or visitor mode run. Okay. Both are supported via P2. So you need to use P2 to prepare your observation. On the left-hand side here, you see your observing run. So your run will appear here. And as written here, you can then click plus. And here you show the content of the run. At the beginning, the run will be empty. And there is the place where you are asked to basically create your OB. So these are buttons that you can use to create observing block, calibration block. You can create a folder if you want to organize your, say, your material into folders, or you can create container, group container, timely container, or concatenation. Okay. Now we start to do, for example, we want to make our first OB. You click, and this is what's happening. So I want you to understand the concept. What happened when I clicked? When I clicked, I create an entry directly on the ESO database. So this is very different from what the concept in the past. In the past, you had to use P2P. With P2P, you were doing the same action, create an OB, okay, but the OB was not in the ESO database. It was locally stored on your laptop or desktop or whatever. This is very different now. Now it's already in the ESO database and is visible in parallel directly. And this is bidirectionally synchronized. So whatever you do is changed in parallel and back. So now, that's very important, in particular, if you are in visitor mode, because it means, especially if you are what we call designated visitor mode, it means you do not go to the telescope, but your slot of time allocated to you as a visitor, so but you are preparing your observation at home. Whatever you do is immediately visible in parallel. And this is of course, a big benefit, okay? But also has some responsibility. You need to understand, every time you do something, you do it on the database, okay? So we encourage you, please test, try, make OBs, but be also careful, try to once you're happy with your setup, you're happy with your creations, try to clean your account, because I mean, you try to not leave too many, template or unnecessary OB into the database. Okay, this is just for a healthy, environment, healthy digital environment. So you create the OB, and the OB gets an OB ID, as you can see, which uniquely identifies the OB in the database. Okay, and you can put a name on it, and so again, on the left-hand side is the content of your account, of your run, and on the left-hand side here you see the content of the item which is highlighted on the left-hand side. So in this case, I highlight the OB, so I see the content of the OB. If I highlight the run, like this, then I see information related to the run. Okay, these are also very interesting information. For example, you see it's very technical, but you see the instrument package version that you use. You see the name of the instrument, the mode. Okay, and then the principal investigation. This is a very complex name, but now because this is a technical account of executor, and then you have the README file that you have to fill. Okay, and now we can do it. This is again Monica gave us an idea. So the README file is critical because it's the set of instructions that you need to convey to the observatory, especially when you are in service mode. And these are very useful for the observer to understand what you do expect from this observation, from your spectra, which are the features that you expect in the spectra, which are the difficulties in the observing strategy that you are putting in. So you put this information here. So now let's go back to the OB. So you created your first OB, and then you give a name. Okay, so you click here very quickly. We call it my OB. Sorry, my fingers are big. My OB, and this is have you seen? So the interface is designed to give you feedback. So every time you do an action, luckily you will have a feedback from the interface telling you what is happening. Again, now I changed the name of the OB, and the name of the OB is already changed directly in the database. Okay, so it's there already and has been stored and saved, and so you do not have so it's there already. Okay, so you don't have to do any backup or anything, so it's already available online. Another important thing, if you log out, then you ask someone else, to your collaborators, to have a look at it, you can, because it's online. So you can, if the person has the credential, you can log in and then work remotely from wherever. So you don't need to export, you don't need, yes? No. Don't make, but I mean, there are no mistakes that, I don't know, what kind of mistakes. But I mean, every time you make it, remember that every time you make an OB, is going to be reviewed by someone before going to the telescope. So any mistakes will be likely spotted. If you made any basic mistakes, is spotted by checks that I will show in a second. So there are checks that we check, verify that the OB is compliant with the basic requirements of the instrument requirements and OB requirements. So he has all he needs. Yeah.
Many people used to export already the OBs to have a backup.
Yes.
And then changed it.
You can do it.
You have this option here.
Yeah. You still have the option to export. You see here, you can export a single OB, or you can even export the entire run. If you click here on the run, you do import export. Here you export the run entirely. So yes, you can always backup and have OBX file, which has ASCII files, and you can work with them and then import them back into the tool. So this is fully compliant still. Yes. So you have your OB. Again, let's give a name. So we want to observe the ONC, just to be. So we call it ONC. Okay. So this part. So here again, sorry. So I highlighted the OB. So here I have a number of tabs. Okay, which are fields that are important, necessary to create the OB. Okay, these are fields that are particular of a single OB. So here you put some user comment. Please just do it. So this is a comment. Do it. Then we can put the instrument comments. Oh my God. So here you put some CNA to noise equal to 10, please. So then then the important point. So you've seen every time I do this, this is automatically saved. So you don't have to press a save button. It will be done automatically. Then, of course, you have to, should be a, yes, now is the first thing that goes. So let me. Why I do not see a bar here? It's there, very beautiful. Okay. Sorry, of course, if you want, since we are working one OB, we can collapse this page, this part, in order to have more space on the interface to work with the OB. So here, again, I show you, if you click on this arrow, so you collapse or expand the observe and run content, so you can work freely with the OB. So here, then you have to add a template. So as you know, the OB is composed of an acquisition template, of the science template. Again, these are things you need to be to understand, and you need to be familiar with this. So please go and read the documentation for Extruder, for example. Here I have the list of my acquisition template. Here I choose the template type. Here I choose the country. For example, I want to do some slit acquisition. Okay. Here, oh, this is the, okay. Again, I don't understand why it disappears. So here I can fill my OB content. Of course, you need to know what to do here. So you need to know the template, and the template is where it is described in the user manual. So please go and have a look. In this case, I want to do the acquisition with a I don't know, R-band filter. 2 seconds acquisition is enough. Then I can add a science template. Okay, and then let's put it stair mode, add template, boom, there, again, yeah, put some exposure time, let's put some exposure time. Of course, here there is a lot of things you can change. You can change the slit, you can change the readout mode, you can do everything. Again, everything is described in the manual. So this is the basic setup of your instrument. Then you go to the, again, let's see here. No, clearly I can't. This is the best browser ever. Windows, right? Okay, then you do here, target. Here, just to show you, we take now that we went to the web. So this is on the web. We are starting to realize that this has beautiful advantages. For example, Tarmed, so you can put your target and use Simbad to resolve your target. Okay, and this is done. So your target field is filled automatically with proper motion and everything. Of course, when you do this, you relies on the fact that Simbad is working. So if Simbad is broken, it's going to be broken as well. So that's part of the, but this is not, so it's not P2, because very often, P2 is broken. No, I'm sorry. So it's communicated with the external server. So we rely on external server. Then, but this is done. So then you can set the constraints that Monica described. So here they are the constraints that you already defined in phase 1, but you can, to a certain extent, relax during the phase 2. Then you can set, and here, for example, we put, instead of photometry, we put thin and image quality 1.3. Let's be easy. And then you can put time intervals in here as well. Now, this is a technical account, but here you will have an overview of the telescope scheduling, so you can check if you have a time critical observation. Then you can, you can basically optimize your window in order to not clash against telescope scheduling. If there are visitor mode or technical account, of course, please take this as a general guideline, because it might be that the schedule this doesn't reflect the fact that there might be half occupancy, for example, the telescope, or partial occupancy. So use it to fine tune, but please be, you can, relax, even go into some of the, so don't take it as an absolute, because also the telescope schedule can change based on day by day activities at the telescope, which are not planned before a priori. Here you can attach a finding chart. You just click and upload it on a JPEG format. Soon there will be probably a possibility to create it directly here. So you click and you create it based on the coordinate that you gave. And then if I verify something, I wanted to show you the target visibility. This, I think, is a very nice tool to see. So we have implemented into the tool. Now you can see if your target is visible and when. So you can somehow, and as you can see here, you have, let me do it with the mouse, since people online can see it. Basically, you can see that your target is visible, and then at some point it's not visible anymore because it violates the air mass, okay? Which you can change. You go back to the constraint set, for example, okay, you put the air mass to, let's say, 1.2. This is automatically saved, bang, you go back, and you see that now it's changed, because of course my air mass now constraint is much higher, so your visibility is lower, okay? So this is a way to have a feeling of how much is visible my OB. And then basically you are done. Then let me I know the time, I mean, don't worry, so I'm here, so we can go through the tool together again. There are many things I wanted to show you, but this is clearly, I did some technical situation. So something I wanted to show you is the following. So once you define your OB, so in the past, we used to say you had to submit your material, okay, to ESO. So submission-wise, because as I was saying, with PWP, you were creating your material, OBs, concatenation, containers, finding charts, ephemerity, everything was ready to go, and then, but it was everything stored in your laptop, okay? So you still had to submit, so to submit to the database. This is not necessary anymore because you are already in the database, but still you need to run some basic certifications. So you need to say to ESO, look, I certified, this is the material which is certified, it's fully ready, so please go on with it. And this is done in the following way. You have two buttons, you have some buttons. You know, the first button's execution time, so you see how much time it does the OB takes. Then you can run the check. So this basically runs some verifications on the OB, and it shows you that in this case my OB is ready to go because it passes the basic verification tests. So that by doing this, by pressing check, it doesn't change anything in the OB. The OB status, the OB condition remains fully editable, so you can keep on working on it. For example, you get a problem, you can solve it. Okay. The difference is that by certifying what is going to happen, look at the OB, now is fully read and write. So if you certify it, it will run the certification, and upon basically positive certification, where is the mouse? Sorry, yeah. It will change the status. You see, it's ticked, bang, certified, and now is read-only. I can't do anything anymore, okay? You can revise this condition, or you can keep it. So basically, what's the point? The point is that you certify a number of items, another OB, or the same with containers, and then you go at the run level, and then you notify ESO. You press notify ESO when you're ready, and everything that's been certified will be basically set to a status which is ready for review by ESO. And ESO will do the review then. So ESO will get a notification, you will get a notification, and ESO will get a notification too, saying, okay, the user has prepared some material, so please do the review. And this is what we call the phase 2 review phase. We will come back to you if there are problems, and you will see basically the status. That's just to show you. Yeah, I know. Okay. I don't know what happened. But so here, just to show you, so there is a flavor of icons, okay, that we put it to help you, to guide you to see which status of OB we are. So, for example, this ticked that say that the OB is certified. When with this I means the OB is already ready in the queues and ready to be executed at the telescopes. And this means that the OB has failed, so is cancelled. You can't do anything anymore with this OB. So something you need to either the period has finished or either the OB has failed. So, but you can see some more details, and I will show you now. And then let's see. Okay, this is good. And another kind of status is this exclamation mark. So when basically you let's say that you submitted the review for the OB for review by ESO will review them, and then we say, oh look, there is a problem with this OB. Then we will mark this OB with this basically icon, so you know that you have that this OB needs some action from you. Okay, and then when you're done, you certify it again, and then you send again the notification to ESO, and then the process will continue. There is another beautiful thing, which is the execution sequence, which is very useful where you are in parallel. And this is for users. They are visitor mode. Basically, you create the execution sequence, which is a sequence of OBs that will be executed at the telescope. Again, this is immediately visible in parallel and back and forward. So it's a very powerful way to proceed with the observation, even remotely. So I stop here. There is more. Please go to our web pages, and let me emphasize that everything that I said is a user interface. The user interface uses a programmatic interface, an API, which is a number of codes, of commands that you can programmatically, if you are an advanced user, you can create your Python script to do everything I showed you via script. So, and this is if you have to create 1,000 of OBs, you can do it very quickly using this interface. Everything is documented in the pages, so please go there and have a look. And if you have a question, I'm happy to answer. Thank you.
Thank you, Giacomo,
and sorry
for this
the
nice, very nice demo. I think you have time for one or two quick questions.
So you said that these OBs are live in the database of ESO.
Exactly.
So is it okay to use this tool in order to, for example, to calculate exposure time before we do the proposal?
Absolutely. We encourage to do that, but please use the demo account.
Only the demo account.
Yeah, that's the best place where to do it. Of course, you can do it if you have your account and you already previews runs with approved, you will see them. So you can, but it's always advisable to do it on the demo account because it's an environment which is, in a sense, out of production. So it's a place where you can safely make your tests. And then something I want to emphasize, the demo account is a public available page. So everything you do there is visible to the world, okay? So this might pose some question of privacy, okay? So the policy that we have in place is that after, typically every week, it will be cleaned, okay? So everything you do is going to be deleted at some point because it's meant to be for tests. So for example, a typical test, I want to know how much time does it take to put my strategy in place. So you go there, you create your OBs, you calculate the execution time, and you will be displayed. But it's very important to use the demo account also because you have always the latest version of what we call the instrument package, which is basically the entity which defines the capabilities of your instrument. So the demo account is really, and also if you want to do some programmatic tests using Python scripts, you can, in the demo account is the ideal place where to do that, because whatever happens, it's not going to endanger the demo, the ESO database. This is very important, I think, point for us.
Thank you. Any more questions for Giacomo? Any questions from our participants online? If not, let's thank Giacomo again.
Thank you.